Hello, and welcome to your first hands-on experience with wireless sensor networks. Today, we're going to take a look at the Arduino Uno, a very small device that will empower us to do great things. As you can see, Arduino is indeed a very small device. It is composed of a programmable microcontroller, which we will prepare some code later on, an USB interface, so we can communicate with it through a computer port, and it also works as a power source. Input and output ports are on each side. Through them we can attach countless things like motors, buzzers, buttons, or other Arduinos. We're going to try to light up an LED at defined intervals, or to blink, with the help of some code running in the Arduino. LED stands for light-emitting diode. They're usually very small, as you can see. It has two legs, a longer one indicating the positive side and a shorter one indicating the negative side. When the voltage on the positive side is higher than on the negative side, the electricity flows through the LED and it emits light. We will connect the longer side to an output pin and the shorter side to a ground or GND pin in the Arduino. Let's start by taking a look at what we're going to need to complete the lab. First, the Arduino Uno, an LED, a Type A to B USB cable to power and communicate with the Arduino, and the Arduino software running on a computer, which you can find and download at the Arduino website for free. Let's power up the Arduino by connecting it to a USB interface on a computer. See how the LEDs light up. Now let's write some code for the Arduino. We begin by installing the Arduino IDE. We can do so by following these commands. And after a while, the Arduino IDE will be installed. We first need to tell the Arduino IDE in which port we connected the Arduino to. We do this by typing the dmesg command in a Linux terminal window. The operating system maps the selected USB port to this address. Now we go back to the Arduino IDE. I configure the port by clicking the Tools board and then selecting the Arduino board that you have. In our case, it's the Arduino Uno. Then, under the same Tools menu, select Port option this time. Then, select the port you discovered with the dmesg command. We have now connected the Arduino board to the IDE. It is time to put some code in it. Click on File, Example, Basics, and Blink. This would load the Blink code into a new window of the IDE. This is how the Arduino code looks like. It is composed by two main functions. Voice setup, here is where you configure all the port functions. The pin called LED, defined at the beginning as 13, is set as an output port. Number 13 represents a built-in LED as well as a physical port in the Arduino. Void loop is an infinite loop. It keeps executing the code as long as the Arduino is powered on. Here we can see that the LED pin is instructed to go high value, then wait for 1000 milliseconds and go to a state low, just to wait 1000 milliseconds again. This will create the blinking effect. To compile, click on the check sign on the upper left corner of the IDE window. Then click on the right pointing arrow to upload it to the board. Look how the transmission and reception LED flash when we transmit code to the Arduino. And now the built-in pin 13 will start blinking. Now let's connect the long leg of the LED to the pin 13 and the short one to the ground. Possibilities are devised from the start when using Arduino. Are you capable of connecting the LED to another port and make it blink? Consider it a challenge. If in doubt, don't forget to check the online course guide, where the process is reviewed in detail. We hope you're able to complete the challenge.